So now we're going to take a closer look at each individual group on the periodic table. So first up, we have group 1, which is also known as the alkali metals. So you'll see this is right here on the periodic table. It's just the first column right there. Again, hydrogen is oftentimes not considered part of this group, just kind of hangs out there, which you'll understand later why it's placed there where it is. But for group 1, they do tend to have just one electron in their outer orbital. Okay, and again, we'll get more into the structure of an atom and what that all means. But one electron in the outer orbital, so they readily will give up that one electron to form +1 ions. Now this makes them highly reactive, so the reactivity actually increases as you go down. So francium is one of the most reactive elements on the periodic table. Fluorine is actually the other one. So francium actually is incredibly explosive. It's so ready to react. These elements, except for hydrogen, will actually react explosively with water, which is why they are pretty highly monitored, I guess you could say. Lithium and sodium are not as explosive, but once you get down to potassium, and then especially rubidium and cesium, they are a lot more explosive. Francium is also radioactive, so explosive and radioactive, not necessarily a great combination. But again, when dealing with these in the pure form, they are, especially rubidium and cesium, they are actually so reactive with water that they can react with the water in the air. So if you have any kind of humidity whatsoever, and these elements are out in open air, they will actually react with that humidity. So when they are used in different science labs and transported and everything, they're oftentimes in oil. So they're submerged in an oil. So there's no way that they can contact water whatsoever. So we do have a video on the Mythbusters working with some of these alkali metals. So group 2, of course, it has to be nice and confusing. These are the alkaline earth metals. So the way I remember it is that group 1 is alkali, it's one word. Group 2 is alkaline earth, it's 2 words. Okay, so we've got beryllium, magnesium, calcium, strontium, barium, and radium. These have 2 electrons in their outer orbital. They like to form +2 ions. Okay, and they are relatively reactive, though they are much more stable than the alkaline metals, or the alkali metals. Next up, we have the transition metals. So these oftentimes get grouped together as one whole thing instead of each individual column. They're weird. Okay, they can form a variety of different positive ions, anything from a +1 to a +7. Okay, so they're kind of strange. There's not like there's not one or two properties that kind of connect all of them, except for the fact that they're all weird, right? So some of the elements can actually form multiple charges. So as you can see in all of this, they are listed, the known charges. Their most common charges are actually listed in bold. Okay, but you'll notice that there is quite a variety of different charges that each element can form, which again is very strange. Because they are transition metals, they are metallic elements, so they are malleable, ductile, good conductors of heat and electricity. Okay, so some of these you might recognize. You've got copper, zinc, silver, gold, palladium, cobalt, iron, chromium, titanium. Okay, and then there are some that you probably wouldn't recognize, like hafnium, yttrium, rhenium, osmium, things like that. Okay, there is also one of the strangest metals. It's part of the transition metals. It's mercury, okay, which is right here. It's the Hg. It is actually a liquid at room temperature, so it is very strange. It's also deadly, so don't ingest it. Okay, though there are some compounds that include mercury that are not poisonous, but mercury on its own is very bad. Hence why they took it out of thermometers, because people kept breaking them and then trying to pick up the weird beads of liquid, and things went bad. Interestingly enough, mercury is actually responsible for what is known as the Mad Hatter syndrome. So if you're a fan of Alice in Wonderland, Mad Hatter, that's actually a condition. They used to use mercury to cure the felt that they used to make hats, and it caused the hatters to go insane, hence Mad Hatters. Okay. Alright, next up we've got some other metals. So here we're just looking at the kind of orangish yellow color here. Okay, they're not the metalloids, so they're not the green ones. But these are solid metals under standard conditions, so like room temperature, sea level pressure, stuff like that. They are also malleable, ductile, good conductors of heat and electricity, because again, they are still metals. You have kind of the weird one, gallium here. Gallium is solid at room temperature, but if you go even like a couple degrees above room temperature, it'll melt. So this is the metal that sometimes you might see what looks like silver and somebody puts it in their hand and it melts. That's gallium. Not necessarily a good idea to hold, you know, that metal and then have it melt in your hand, but it's cool looking. So they have high density, and aluminum, gallium, indium, and thallium. These four right here will form +3 ions. Tin and lead can form +4 or -4 ions, and there is some +2s that can get thrown in there as well, but for the most part +4 or -4. And then bismuth, right over here, likes to form -3 ions for the most part. Alright, then we've got the metalloids. So these are the ones in green. So again, they will look like metals, but they behave like non-metals. So they're the really kind of weird ones. They are shiny, but they are brittle, so very unlike regular metals. Okay, they are kind of intermediate to relatively good conductors. You're known as semiconductors. Boron will form +3 ions. Silicon and germanium here can form +4 or -4. Arsenic and antimony can form -3. Arsenic, interesting fact, is a poison. I know it's wonderful, all these little interesting facts here, but arsenic at high levels is a poison. At lower levels, it's actually found in almonds. So another kind of interesting fact is that people who eat almonds on a regular basis actually develop something of a tolerance for arsenic. So, little life lesson there. And then you've got tellurium and polonium will form -2 ions. So those are the last ones over here. Okay? And again, some of them, like especially further down the periodic table, can form a bunch of different ions and they get really weird. But we'll get into all of that in the coming chapters. Alright, next up we've got the nonmetals, and this includes hydrogen. Okay, so these are the kind of purpley looking ones here. So these are poor conductors. Okay. If they are solid, they are generally brittle solids, so like phosphorus kind of flakes a little bit, so does sulfur. They have little or no metallic luster, which means that they are very dull. Okay, they aren't shiny like the metals that you are most familiar with. You can't polish them to get them shiny. Hydrogen will form +1 ions. Carbon, if it does form an ion, will be +4 or -4. Nitrogen and phosphorus like to be -3, and then oxygen, sulfur, and selenium will form -2 ions. Okay. Next up we have group 17. These are the halogens. Again, fluorine is one of the two most reactive elements on the periodic table. They have 7 electrons in their outer orbital, which means that they like to grab any and every electron that they can find. So they are highly reactive. Basically, any electron they find, they will grab it and react with whatever it was on. So they are kind of like the muggers of the periodic table, especially fluorine. They readily form -1 ions, okay, and then the reactivity increases as you go up. So again, fluorine is the most reactive here. Alright, finally we have the noble gases. So this is group 18, we're on the far right side of the periodic table. So we've got helium, neon, argon, krypton, xenon, and radon. Okay. So they have 8 electrons in their outer orbital. Now each element wants to get 8 electrons in their outer orbital. So that's why these elements are happy. So they are mostly non-reactive. In fact, it took a really long time for them to be discovered because for the most part, scientists were just discovering elements based on their reactivity. So it took forever for these to be discovered simply because they do not react for the most part. When you get up to krypton, xenon, and, well, not really radon because that one's radioactive, but krypton and xenon especially, they will react simply because they are so large that the inside of the atom doesn't really know what's going on the outside, and reactions take place on the outside of the atom. Okay. So they don't generally form ions, though you will see krypton and xenon form some every once in a while. And then we do also have 2 more rows on the periodic table that don't really seem to fit in there. First up we have the lanthanides. So they get their name based on the element that comes first in this row, lanthanum here, element 57. They fit into the table after element 56, barium here. Okay, so they would go right in here, right? Sometimes you'll actually see where they pull Lu here, they pull that down over to here and just put like 57 to 71 in this box. Okay, but only promethium is radioactive in its most common form, but for the most part a lot of these are synthetic, so they are not naturally found, so they have to be created in a lab, though there are some that you will find, but for the most part they are synthetic. Then you have the actinides, so they get their name again from actinium, which is the first element in this row. Okay, so you'll notice that when you get up to these elements, a lot of them seem to have somewhat familiar names like thorium. And then you have neptunium, plutonium, americium, curium, berkelium, named after Berkeley, the university. And you've got californium, einsteinium, mendelevium, nobelium. So some of those are obviously named after states, others are named after famous scientists. Yeah. So they will fit into the periodic table after element 88, which is radium. Okay, so they go right in there. And again, most of these are synthetic, and all of them are radioactive. So you'll notice uranium is in this. Okay. Thorium and uranium do have a stable isotope or a stable form, but for the most part they are all radioactive. And then you do have your unknown elements. Again, these have been named. And I'm actually almost out of time in this video, so we're going to save that for the next video.